Welcome to Beans and Bedrock.
Hello everyone and welcome back to Beans and Bedrock. I hope you're all doing great. My name is Anupam and on this channel we dig into software engineering, Java, Spring, AWS and AI, one topic at a time. So let's get started. Today we're talking about one single line of code, one annotation, probably the most used in the entire Spring ecosystem. And I'd bet money it's also the most misunderstood. People sprinkle it onto a method, the tests pass, everyone moves on. And then one Friday evening, production has an order that got paid for twice, or stock that vanished from a warehouse that never sold anything. The annotation is @transactional. By the end of this video, you'll know exactly what it does, how it does it, and where it quietly does nothing at all. This is the @transactional annotation in Spring. Alright, before we touch any code, let me take you somewhere completely different. A restaurant kitchen, dinner rush. Table 12 has ordered 4 things: a risotto, a steak, a salad, and a bowl of soup. And 4 different cooks are making those 4 dishes at 4 different stations at 4 different speeds. So the soup is ready first. Does a waiter grab it and run it out? Absolutely not. It goes onto a steel counter under a heat lamp, the pass, and it waits. The salad lands on the pass, then the steak, and standing at that pass is one person, the expediter. Their entire job: look at the ticket, look at the plates, decide one thing. Is this table complete? Nothing leaves until they say so. And when they say it, one word: away. All 4 plates go out together. Now here's the interesting case. The risotto burns. They don't send 3 plates out and leave one poor person watching everybody else eat. They scrape the pass. The table gets nothing. And the whole order gets made again, properly. All of it or none of it. That's the rule. That counter under the heat lamp, that's a database transaction. Calling away, that's a commit. Scraping the pass, that's a rollback. And in Spring, the way you put an expediter on a method is a single annotation. So let's see what happens when you forget to. Here's our code. An ordering service, the kind of thing in every backend you will work on. @service, public class order service. 3 collaborators injected in: an order repository, an inventory repository for stock levels, and a payment client for taking the money. And here's the method: public void place order, taking an order. Line 1, orders.save order. We write the order row. Line 2, inventory.decrement stock. The customer bought 2, so take 2 off the shelf. Line 3, payments.charge. Take the money. Read that top to bottom. Looks completely fine, doesn't it? 3 steps, 1 job. But it isn't one operation, it's 3, and I need you to sit with why. Each of those repository calls opens its own transaction, does its work, and commits immediately before the next line runs. Spring Data's repository methods are themselves transactional. If no transaction is already running, each call starts one and closes it. Line 1 commits, line 2 commits, then line 3 throws, card declined. So what's in your database right now? An order row saying the customer bought something, stock taken off the shelf, and no payment, ever. 3 plates went out, the 4th one burned, and nobody scraped the pass. And trust me, I've shipped that exact bug myself. It never shows up in tests, because in tests, the payment always succeeds. It shows up at 2 in the morning in a spreadsheet from somebody in finance. So, let's fix it. One line. That's the fix. @transactional on the method. That's the entire change. But don't just copy it. Know what it bought you. That's the difference between using Spring and fighting Spring. So here's what happens at runtime. Before your first line of code executes, Spring opens a transaction and binds a database connection to the current thread. Then your method body runs. Orders.save joins that transaction instead of starting its own. That's the default propagation required. Join a transaction if one exists, start one if it doesn't. Inventory.decrement stock payments.charge, same transaction. Nothing is committed yet. Every one of those changes is a plate sitting on the pass. If your method returns normally, Spring commits all of it at once. If it throws, Spring rolls the whole thing back. Your database never saw a half-finished order. And now, the part I really want you to take away from this video. Ask yourself, how is that even possible? You didn't write a single line of begin or commit or rollback. Something is running code before and after your method, and you never called it. Here's the answer, and it's the thing that makes everything else about a transactional make sense. Spring does not add transaction code inside your method. It can't. Instead, when your application starts up, Spring hands out a fake order service, a proxy, a stunt double that wraps your real object. And every single call has to walk through it first. Open the transaction, call the real method, commit or rollback. The bean you injected is not your class, it is a wrapper around your class. And once you see that, every strange transactional bug you have ever hit suddenly explains itself. Okay, step 2, and this one is a genuine trap. When does Spring actually roll back? Because it threw an exception, so it rolled back, is only half true. And the missing half has cost real companies real money. Watch. Suppose our payment client throws a checked exception. Payment declined exception extends exception, not runtime exception. So place order now declares throws payment declined exception. Same annotation, same method. The payment fails. The exception propagates out. Does Spring roll back? No. It commits. Let me say that again, because it's the single most surprising default in Spring. Out of the box, a transactional rolls back on runtime exception and on error. And it commits on checked exceptions. Spring treats a checked exception as an expected business outcome, not a failure, so it finishes the transaction as if everything went fine. Same broken data as before, plus an exception in the logs politely telling you the payment failed. The kitchen sent the food out while the risotto was still on fire. The fix is to be explicit. At transactional, rollback for equals payment declined exception dot class. Now that checked exception rolls back to, or the blanket version, rollback for equals exception dot class. Rollback on anything. My honest advice, pick a convention on day one. Either use runtime exceptions for anything that should abort the work, or put rollback for equals exception dot class on the methods that matter. Step 3. 2 gotchas that come straight out of that proxy plus 1 free performance win. Gotcha number 1, the internal call, same class. We add a batch method, place order batch, looping over orders, calling place order for each one. Place order still has a transactional on it. So how many transactions do you get? 0. Not 1 per order. 0. That call to place order never leaves the object, so it never passes through the proxy. And the proxy is the only thing that knows how to start a transaction. Spring never sees it. The annotation is just decoration. Brutal, right? The code looks correct. It compiles, it does the work, with no transaction at all. The fix. That call has to come from a different bean. Move the loop into its own class, inject order service into it, and every call becomes a real external call through the real proxy. 1 transaction per order, exactly like you intended. Gotcha number 2, swallowing exceptions. We're inside a transaction, calling an audit service that's also transactional. It throws. We catch it, log a warning, carry on, Auditing isn't critical, right? Then at commit time, Spring throws unexpected rollback exception. Transaction silently rolled back because it has been marked as rollback only. Why? Because that inner method joined our transaction, and when it failed, it flagged the shared transaction for rollback. Catching the exception hid it from you. It did not unflag the transaction. The fix: when that inner work genuinely is independent, propagation equals requires new. That suspends your transaction and runs the audit in a separate physical transaction, which can fail on its own without touching yours. And the free win, read only, equals true on query methods. It tells Hibernate to skip dirty checking and flushing, because nothing's going to change. Okay, we saw all of this. Let's quickly do a recap. The problem: a method that does several writes is not one operation. Each write commits on its own, so a failure halfway through leaves your database in a state that should never have existed. The fix: add transactional on the public method that represents the whole unit of work. Spring wraps that bean in a proxy, opens one transaction around your method, and commits or rolls back all of it together. Add rollback for when you throw checked exceptions, and requires new when one piece truly has to stand alone. The payoff: all or nothing writes, no half-finished orders, and no more 2 in the morning spreadsheets from finance. And that's the at transactional annotation. One line, and a proxy quietly doing all the work behind it. Go open the biggest service method in your codebase and ask, if line 3 throws, what does line 1 leave behind? See you in the next one.